Hello everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. In this lecture video, we are going to discuss about the introduction of transportation problem. So what is transportation model? Transportation deals with the transportation of a commodity, that is a single product, from M sources, that means origins or supply or capacity. Level of supply at each source and the amount of demand at each destination, and the unit transportation cost is cost of that commodity from each source to each destination are known, or otherwise it is given. It is also assumed that the cost of transportation is linear. The objective is to centers to end destination, that means sinks or demand or requirement centers. It is assumed that determine the amount to be shifted from each source to each destination such that the total transportation cost is minimum. That is objective of transportation problem. So what is a mathematical formulation of transportation problem? Let us, there are M sources and N destination. Let AI be the supply or capacity at source I, Pj be the demand at the destination J. Here Cij be the unit transportation cost from source I to destination J, and Xij be the number of units shifted from source I to destination J. Then the transportation problem can be expressed mathematically as minimize Z is sum of I takes from 1 to M and the sum of J takes from 1 to N, Cij Xij. Subject to the constraints, sum of J is equal to 1 to N, Xij is equal to AI, I takes a value 1 to M. And sum of I is equal to 1 to N, Xij is equal to Pj, the J takes a value 1 to N, and the Xij all are positive for all I and J. The two sets of constraints will be consistent if sum of AI, that is total supply, and the sum of Pj, total demand, if these two are equal. First we check it, the total supply and the total demand, which is a necessary and sufficient conditions for transportation problem to have a feasible solution problem. Satisfying these conditions are called a balanced transportation problem. So when a transportation problem is balanced, the sum of total supply and the sum of total demand, if both are equal, then we get a feasible solution. If it is so, the given transportation problem is balanced. Otherwise, the sum of total supply and total demand, if both are not equal, the problem is unbalanced. Here the standard transportation table is shown. Transportation problem is explicitly represented by the following transportation table. Here the destination and supply. The destination D1, D2, D3, etc. Dn. There are n destination, and the supplies, there are n supplies. So C11, C12, C13, etc. C1j. And C21, etc. and so on, CM1 up to CMM. These are all unit cost. And supply. So in this source 1, there are A1 supplies available. In source 2, A2 supply available. In source 3, so on up to source Sn, AM supplies are available. And the destination sum demand side is a D1 demand, there are B1 demand. In D2, B2 demand, D3, B3 demand, and so on, Dn, Bn demand. So how? First we check whether the given transportation problem attain a feasible solution. That means the total supply and the total demand, whether the total supply and the total demand are equal or not. First we check it. So total supply is AI, total demand is Bj. So sum of A is equal to sum of Bj. If it is true, then the given transportation problem attains feasible solution, that is balanced. Now we have some of the various definitions of these transportation problems involving a set of non-negative values xij, that is I takes the value 1 to m, j takes the value 1 to n, that satisfies the constraints is called a feasible solution to the transportation problem. So what is feasible solutions? So all the constraints satisfy, all these non-negative values satisfy the constraints of the given transportation problem, then it is feasible solutions of the transportation problem. Next one. There are feasible solutions to a m by n transportation problem that conditions no more than m plus n minus 1 non-negative allocations is called a basic feasible solution to the transportation problem. That is, a feasible solutions of m cross n transportation problem that conditions no more than m plus n non-negative allocations. Here, m is number of rows and n is number of columns. Then the transportation problem having basic feasible solution. Next one. A basic feasible solutions to a m by n transportation problem is said to be non-degenerate basic feasible solution if it contains exactly m plus 1 minus 1 non-negative allocations in independent positions. Next one. A basic feasible solution that contains less than m plus n minus 1 non-negative allocations is said to be degenerate feasible solutions. In our transportation problem, definitely the solution must be a non-degenerate solutions. Okay, the next one. A feasible solutions that is not necessarily basic is said to be an optimal solutions if it is minimize the total transportation cost. So you fix that the number of basic variables in an m by n balanced transportation problem is at most m plus n minus 1. So how many basic variables involved in the transportation problem? M plus n minus 1. That is m rows and n columns minus 1. That much of occupied cells are entered into the transportation problem. Okay, suppose the problem is a degenerate. Suppose the given transportation problem become degenerate. How resolve degenerate problem? So what is degenerate problem? How resolve this? In a transportation problem with m origins and n destination, if a basic feasible solution has less than 30 m plus n minus 1 allocations, then the problem is said to be degenerate transportation problem. So how resolve the degeneracy? So we create a dummy epsilon in an independent positions, and then it makes m plus, and then the number of these occupied cells are equivalent to this m plus and minus 1 allocations. Then if these two are equal, then become non-degenerate. So that's all this video. In next video, discuss about the how find the initial basic feasible solution using different methods of transportation problem. Thank you.